Alright, so the first thing that we're going to do is, I'm sure you already have these notes, but parts of the atom. Basically, you have the protons, which are positive. Forget my spelling. Electrons, which are negative. And neutrons, which are neutral. So I'm sure you already have these notes, and these ones as well. So these are the shell, and these are more important because you learn how many are in each shell. But I'm sure you got these as well. So we're going to go ahead and pull the periodic table. Like lithium. Maybe. What's this? So we have lithium, which is Li, and lithium wants to become a noble gas, which is what we call these guys right over here. So for lithium to do this, lithium has to lose an electron. But the way the shells work, so you have 3 electrons, and there's your nucleus. 2 in the first, and up to 8. But this 1, because there's 3, you only have 1 positive. So that's how that works. And you always want to have a filled shell, which is 2, 8, 8, 8, 8, and so on and so forth. So it gets us into the newer stuff, which is where I believe you're going wrong. You have what's called binary. Binary. Bi meaning 2 atoms. Not really atoms, but elements. So what we do here now is we find 2 elements that we like, and we have to make them combine. So we have, let's take magnesium, Mg, and chlorine, which is Cl. Magnesium, which is right here, wants to go over to 1 and 2. And chlorine, here, yeah, wants to gain what? Let's not do chlorine, let's do sulfur. So that's sulfur, which is S, wants to gain 2 electrons. So Mg, So magnesium wants to get rid of 2. So magnesium has 12 electrons. And it loses 2. Then it now has more protons, thus becomes positive. And sulfur wants to gain 2, but so it has more electrons now, so that means that it has a negative charge. And these fit right together because 2 minus 2 equals 0. So that is perfect. And your answer, MGS. Now, you have, now today, or more complex, we'll go to more complex. First, we'll go to something like beryllium and carbon. Now we'll not do carbon, let's do nitrogen. Beryllium has 4 electrons. And so we write it as 4 equals 4. Here you have nitrogen, which is M7. Now these, positive and negative, these don't go together. Well, they do, but you have to include subscripts. So you find the least common multiple, which is 7 times 4, which is 28. So for 4 to get to 4 divided by 28 is 7. And for nitrogen, times 4. So there you have the subscripts. So that is basically all we did in class today. But he introduced these Roman numerals: 1, 2, 3, and 4, and so on and so forth. So when you take these section, which is called the transition elements, you have to, there's different ways, because you can subtract and go this way, or you can add and go this way. So there's different kind of elements or ions that you can make. So what we do is we take something like iron, Fe, and we put a Roman numeral in front of it, type 2. So that means all you have to do is take this and decipher it as a 2, which is pretty simple. And that becomes your exponent. And then these are binary, so you have to have your other one. You go out and you find like oxygen. Very simple. Oxygen Oh, by the way, these are always going to be positive. Always going to be positive. And then you mix it with oxygen, which wants to lose 2. So these fit together pretty fine. Fe, oxygen, so just like that. So that's iron oxide for the name. Now, if we wanted to, we have some more tricky ones, which is no really different from this down here when you find the least common multiple. But if you were to have iron 3, it's a 3 by the way. Do that again. 3 oxygen. You have iron to the 3rd power, and then you have oxygen, which is a -2. But what do you do now? Like this, you have to find the least common multiple, which in this case is 6. So how many times does 3 go into 6? 2 times. How many times does 2 go into 6? 3 times. So oxygen 3. And that's what we were doing in class basically today. The last question he was just talking about the polyatomics, and I don't really think you need to know. You need to know like what they are and stuff, but not actually how it mixes with these yet. What else do I write? Pretty much it. Essentially, what you need to learn is every one of these want to have 8 in their outermost layer. That's 8. This is 8 noble gases. So if you have 7 in your outermost layer, then you want 1 more. If you have 3, you're going to try to lose 3. So everyone becomes 8. And yeah, that's pretty much it. Knowing that just how to make 8 will get you your exponents, and then your exponents combine together to break even. They always have to be electrically neutral. And all that good stuff. The outer shells always have to try to make 8. And by the way, these are always the way there's 3 kinds of bonds: ionic, which is where you connect them like I'm trying to think of one. Salt, table salt, chlorine. They fit together because this is a -2 and that's a +2. They fit together, I believe. This is just from memory, so I'm not sure. But they fit together, so that's an ionic bond. There's a covalent bond. That's not how you spell it, but close enough. And that's where you have like water, H2O. You have hydrogen, which has which has 1, obviously. Yeah, see hydrogen right there. And then oxygen over here, which wants 2. So hydrogen is 1. Oxygen wants 2 to fill up. It needs 2 more. It has 6 right now. It needs 2 more. So what does it do? It says, hey, we share 1 here, we'll share 1 here. And hydrogen's happy because it has 1 here and 1 here for a total of 2, which fills out the first layer. And oxygen's happy because it has a total of 8, 6 here, 1 here, 1 here. And covalent bonds share them, so it's more of a right here, figure 8 kind of pattern. Which I can show in a different color. So it does that kind of, and then there's magnetic bonding, which is just about the polar sides of the bonds and how they connect, but we don't get into magnetic right now. But essentially, you know your bonds, you know that they connect together and they have to always be electrically neutral, so equals 0, exponents must equal 0, -3, +3, 0, always. And know your Roman numerals equals what they do. And that's pretty much the lesson.